Welcome back, everybody. This is going to be the homework review part 2 for lesson 38, finding the volume of truncated cones. And so in the first one, part 1, we saw that there was a lot of us finding two different volumes, finding the original cone and then the part that's cut off, and then the difference would be the volume of the truncated cone. And here we have the same kind of technique to use for our truncated pyramid. All right, so we have this I would say in this case a truncated pyramid where the top base is going to be based upon the square whose measure is 3 feet, and the top base would be a square whose side is measurement of 2 feet. And so, and of course the difference is 5 feet though. But we need to find the original pyramid height though. So here's the thing, we use the same exact concept here from before. So we're going to measure this. Now, this measurement here is going to be not 3 feet, but 1.5 feet. And this measurement here is not 2 feet, but 1. So, because again, it's down the center, through the center of the pyramid. Okay, and so now this measurement here, okay, this measurement of the is to be 5. Well, we'll call this x. So the original height of the pyramid would be x plus 5. And again, we have similar triangles, and the idea of corresponding sides of similar triangles are proportional. So let's go with the big similar triangle, the x plus 5, the height over its base, which is 1.5, is equal to the height of the small triangle, which is x over 1. And so what we're going to do is we're going to cross multiply, and in this case we cross multiply, we're going to get in this case x plus 5 equals 1.5x. Okay. All right, so, well, now we just subtract x on both sides, and we get 5 is equal to 0.5x, divide both sides by 0.5, x equals to 10. So now we need to find the volume of the cone, sorry, the volume of the pyramids. We know our height here is going to be 15, and this is going to be 10. So let's find the volume of the big pyramid. So the volume of the truncated pyramid, truncated TP, equals the volume of the big pyramid minus the volume of the small pyramid. And so the volume of the big pyramid is, now remember, it's 1/3 base area times height. So since it's a square base, it'll be 3 squared times the height, which we found to be 15. And the volume of the small pyramid is 1/3. It's a square base with side 2, so 2 squared times a height of 10. And so now what we do is we get the following. So we put together. Now we can actually find each value. So here, if we do 1/3 times 9, because 3 squared is 9, that's 3 times 15 is 45. Okay? And if we do, now this was a little bit trickier because the fraction 1/3. Well, 2 squared is 4, times 10 is 40, so 40 divided by 3, so 40 over 3. Now we want to determine the volume of the monument to the nearest tenth of a cube. But so let's now take this, so 40 divided by 45 minus 40 over 3. So let's make a calculator and clear this. All right, so 45 minus 40 divided by 3. Oops, hang on a second though. I was gonna make an error. So I'm gonna do this here. I'm gonna just delete this. Actually, no, it will be 45 minus 45 divided by 3. That's exactly should be. All right, so, and we get 31.6 repeating. All right, probably because in this case the 40 divided by 3 is going to be, I believe, 13 1/3, and of course you do the math there. 45 minus 13 1/3, you get 31.66 repeating, or so 31 2/3. Okay, but the nearest tenth of foot would be 31. So our difference, so volume of the truncated cone, is 31.7 cubic feet. Okay, so that's going to be our volume here. Okay, all right. Sorry about that, ladies and gentlemen. All right, so we want to first found the height of both the original small pyramid on top and the original pyramid, and we find the volume of each one and subtract. Now for the second part, if the monument is made from marble that weighs 170 pounds per cubic foot, how many tons is this monument to the nearest tenth of a ton? If you don't remember how many pounds are in a ton, do an internet search. Now we don't have to. Okay, there are 2,000 pounds in 1 ton. So, okay, so here what we're gonna do is we're gonna take our weight of our volume of 31.7 cubic feet. Okay, and we're going to multiply this by 170 pounds. Okay, and so this is going to give us the total weight in pounds. But after that, we will then divide this whole thing, because the conversion will be 2,000 pounds per ton. All right. Now we'll compare. In this case, we'll compare the 31.7 to the 31 2/3, which is 0.6 repeating, and see if there's a big difference. Because we again to the nearest tenth of a ton, and we'll see if that matters. Okay. All right. So let's go to our calculator. All right. So we have in this case 31.7. Well, let's take a that's fine though. So 31.7 times 170, because it said 170 pounds per cubic foot, and divide that by 2,000. And we get 2.69, which rounds off to 2.7. Okay? All right. And so now let's take a look. Let's see, let's go back to let's see if we can take our original number and see if it matters. Let's go back to here. Okay, enter. All right, and then we'll do the same thing, times 170, and then divide by 2,000. Yeah, hopefully your calculator can do that. No, otherwise you'll have to redo the step 45 minus 40 over 3. And so we find this to be 21.69166666 repeating, but to the nearest tenth, it becomes out to about 2.7 tons. So it approximates to 2.7 tons. So this will be the weight we have here. All right, so it's full page, so we can take a look at everything. All right, so for this question, again, the original the design is very similar to that of finding the truncated cone. What we're going to do is we're going to set up a proportion of our two triangles, the original triangle, the height of x plus 5, and our base will be, in this case, 1.5. It says 15, but it really should be 1.5. There you go. All right. And with the height of the small triangle, which is x over the base of 1, and we cross multiply to get x plus 5 equals 1.5x. Solve for x, and we got x to be 10. We use those dimensions here to find the volume of our large original pyramid. So our original pyramid would be, in this case, 1/3 times base area times height, which is 3 squared times 15. And in this case, we got a total of 45 for that. And then, of course, 1/3 times the base area of the small pyramid, which is 2 squared, 4 times 10, we got 40 over 3. And from there, we found the volume to be about 31.7 cubic feet. Then we use our math here to multiply the volume by the weight of the weight of the marble, because that's what the monument is made of, and then divide by the number of pounds, 2,000, to get how many tons. Ladies and gentlemen, this is the end of part 2 of our homework review. Part 3 is going to be interesting because you're using your own cup, if you will. I will be picking a cup, and I'll give you the dimensions. If you want to use my dimensions too, that's totally okay. It's a matter of just trying to figure out the same thing. And I'm going to be rounding off a little bit too. I just got to find my little ruler here. But thanks for watching. I hope this was helpful to you guys. I've been a little bit trying to keep up with things a little bit. No, I hope that this was if it's helpful, please leave a like for the video. If you have any questions or comments or even feedback, please leave it in the comment section below. Make sure you subscribe to our channel and turn on notifications, because I know sometimes I post on the channel and don't put it on the Google Classroom, and because I forget. But those of you who subscribe, you already know when the video is up there. So okay. In any case, I will look forward to seeing you in the next video and just trying out this whole thing with a truncated cone cup I have from school. Actually, it's a orange Cardozo high cup I got. So it says I love Cardozo. All right, so I'll give you the measurements for that, and then we'll work from there. Okay, thank you so much for watching. Take care, be safe, and see you in the next video.